Hi, I'm Alex from the Zscaler Customer Success and Engineering team. In this series of short videos, we're taking a look at the baseline recommendations for configuring cloud firewall policy inside Zscaler Internet Access. This is part 4, taking a look at the model policy and some policy examples. Before we look at the model policy, let's take a few seconds to understand the basics of how firewall control policy works. First, when you look at a brand new tenant, you'll note that there are predefined rules at the top. These include rules for Zscaler maintained list of IPs and ports that are used for our own services, the Zscaler proxy traffic rule, or for certain third-party services like UCaaS or Office 365 if those one-click rules are enabled. Next, you'll note that a default block policy is in place for new tenants. If your tenant is over a certain age, you may find that this is not the case and you'll need to make some policy changes. This default block policy is aligned with common cybersecurity best practices. This allows web traffic and blocks all other protocols and ports. This means that if you want to allow, for example, SSH, FTP, RDP, and so forth and so on, you'll want to build a list of business-approved destinations for these services, and then build policy that allows these services for those specific destinations. It's also recommended that you further narrow these policies by applying match conditions, such as user identity conditions if you have the advanced cloud firewall licenses, for example, users or groups, and locations, sublocations, and source IP addresses and groups, which are available as criteria for both the basic and advanced cloud firewall licenses. Let's now take a look at our model policy. First, it's important to understand that, like with all other ordered and numbered lists of rules inside ZIA, rules here are evaluated top-down, and the first matching rule is the one that's applied, with subsequent rules not being evaluated. With that said, let's start taking a look at these policies. First, we'll note that at the very bottom of our list, we have a default block all rule. As mentioned on the previous slide, this is recommended cybersecurity best practices. Having a default block behavior like this will ensure that only traffic flows that you're specifically choosing to allow through are allowed through the firewall module, and all other flows are blocked. This helps minimize unforeseen gaps in your security perimeter. Next, we have our predefined rules. These include rule number 1, the Zscaler proxy traffic rule, which allows traffic to Zscaler proxy IPs for Zscaler proxy network services, and various one-click rules depending on what you've enabled, for example, UCaaS one-click rules for Zoom, WebEx, etc., and the Office 365 one-click rule for Office 365. These allow traffic to the listed destinations. Rule number 3 in the model policy blocks the QUIC protocol. At present, this traffic cannot be decrypted and security policies cannot be applied to it. As a result, it's recommended that you configure a block ICMP rule for the QUIC protocol. By configuring a block ICMP action, this will ensure that the source applications are notified by the block and are able to fall back to TLS quicker rather than waiting for a timeout, as would be the case with a silent block. Note that this is the only rule that is set to block ICMP instead of block drop. In general, you'll want to configure block drop rules for firewall blocks. These are silent blocks that do not notify that a block has happened, which means that the source cannot attempt to get around this by trying a different port or protocol. It's important to do this, both to control these network flows and make sure they're blocked, and also to make sure that threat actors cannot use block notifications to build a map of what ports and protocols are allowed or blocked by your firewall rules. Note also that the rule to block QUIC is placed above the Office 365 one-click rule. This is because in cases where we want to inspect and control Office 365 traffic, for example, to inspect OneDrive or SharePoint traffic, for malware or DLC policy, we need to ensure that Office 365 does not leverage QUIC. This rule is below the UCaaS one-click rules, as we don't really care if UCaaS uses QUIC traffic since there's no known exploits for voice and video traffic. Rule number 5 is a Zscaler created rule that blocks malicious IPs and domains. This pre-bit rule is updated by the Zscaler Threat Intelligence team. This is a reasonably new rule. If your tenant is over a certain age, the rule will have been created but not enabled in order to avoid impacting your production tenant. It's recommended to enable this rule and to keep it enabled. This ensures that you get the maximum amount of protection from the Cloud Firewall module by blocking known malicious IPs and domains. In case of false positives, you can create an exception rule above it to allow the specific IPs or domains that you think should not be blocked. And then you can notify Zscaler directly via support ticket to request an evaluation of those destinations and make sure the false positive is lifted. Rule number 6 allows web traffic, these are the network services HTTP, HTTPS, and DNS, to allow your users to browse the internet. Finally, we have rules here 7+, 8+, and 9+, which really will be multiple rules for each individual category. This is where you'll want to place any rules that you specifically create. At the top of this block, you'll want to place policies specific to user groups. with whatever criteria you want to configure. Destination and source IP, country, network services and applications, URL categories, device type, or trust. Note that the ability to leverage user context in rules is a feature of the advanced firewall license. If you have only the basic firewall license, you won't be able to use these criteria. Note also that it's recommended to use groups and not users here, as you can only select up to 4 users in a rule. Below this is where you will place policies specific to location groups. Finally, below that, but above the block all default rule, is where you'll place any global category-based blocks that you create to block specific flows for all users. Next, let's take a look at a couple of examples for specific policies we can build. First, let's look at how we can build policy to restrict SSH to trusted destinations only, since allowing SSH to any destination may expose potential data exfiltration pathways. To do this, we'll start by configuring a trusted SSH IP refqdn destination group. This is done via administration, IP, and FQDN groups. Here, we'll enter the IP addresses, or FQDNs, for any destination that we want to consider a valid, trusted SSH destination. Next, we'll build our allow rule. We'll configure a rule name and the rule order, placing it below the allow web traffic rule inside the policy list. We'll want to select SSH as the services, a destination group of trusted SSH, and an action of allow. After that, you'll build your block rule. Again, we'll give it a rule name and order. Here, placing it below the allow rule, we'll select SSH as the services, and an action of block reset. The final rules will look like this. Here, Rule 7 allows SSH to the trusted destinations, and Rule 8 blocks SSH for all destinations. Since rules are evaluated top-down and only the first matching rule is applied, this means that SSH traffic to our trusted destinations will be allowed, and SSH traffic to all other destinations will be blocked. For our second example, let's take a look at how you can restrict RDP to specific users, since being able to RDP to external machines can allow users to bypass security policy and exfiltrate data. Note that this example relies on user context to target policy, and therefore is only possible with the Advanced Cloud Firewall license. To start, we'll build a custom network service. We'll go to Administration, Network Services, add a network service, and configure a service with a TCP destination port of 3389, since this is the RDP port. Next, we'll build our allow rule. We'll give it a name and place it somewhere within the block of custom rules as established while covering the model policy. Here, let's say we make it rule order 9 so that it fits below the 2 rules that we just created to restrict SSH to trusted destinations. We'll configure user groups as the who, where, what criteria, selecting, for example, our developer team and IT admins as the groups that are allowed to RDP. For network service, we'll select the network service that we've just created, our custom remote desktop network service. For the network application, we'll pick RDP, and for the action, we'll pick allow. One thing to note here is that when creating policy for specific applications, you want to make sure you always select the network service and network application together as criteria to ensure that it's not possible to use a non-standard port or protocol to bypass the rules. Next, we'll build our block rule. Again, give it a name, place it below the rule that we've just created to allow RDP traffic. Select the RDP network application and an action of block. Here you can see what the example rules we've just created look like inside our policy list. Rule number 8 here is the block SSH rule we created in the previous example. The number 9 allows RDP for specific user groups. And rule number 10 blocks RDP for all users. Again, since rules are evaluated top-down, the first matching rule is applied. This means that RDP will be allowed only for the users in the ZS developer teams and ZS IT admins groups. And any user not in this group will not match this rule, so the next rule will be evaluated for those users, which is the block RDP for all users. Finally, one thing that's important to understand is that it is possible for traffic to attempt to avoid firewall rules by using non-standard ports. To prevent this from happening, you'll want to go to Administration and Network Services and configure network services for all known non-standard ports that you wish to control. Then you could go to Administration Advanced Settings and add your custom network services to the appropriate services forwarded to the HTTP web proxy section. With Advanced Cloud Firewall, this is much easier, as you can simply go to Administration Advanced Settings, and then enable all auto-proxy forwarding for non-defined ports options, which will use DPI to identify traffic and auto-forward it to the proxy module. Before I end this video, let's take a look at several specific recommendations for configuring firewall policy. First, as a reminder, Firewall and IPS controls are enabled per location or sublocation. So it's important that after you've configured your firewall policy, you go to your location settings and enable firewall filtering for those locations. If these are not enabled, then traffic from those locations is not subjected to the firewall and/or IPS policies and is passed directly to the internet. This can also mean that other security policies are not enforced, since traffic is not classified by the firewall module. Next, under Advanced Settings, you should enable policies for unauthenticated traffic. Note that by default this is disabled. If disabled, there is no way to match unauthenticated traffic explicitly in a policy rule. Examples of unauthenticated traffic includes guest Wi-Fi, IoT, server traffic, and so on. Note that default catch-all rules that don't have specific matching criteria will still apply to unauthenticated traffic, for example, the restrictive default block rules. Enabling this setting will allow you to apply policies granularly to this unauthenticated traffic. Also, advanced settings, you should enable the firewall settings for Sentinel 1.0 and Pack Road Warriors setting. Again, this is disabled by default, but should be enabled. Enabling this setting will make sure that firewall policy is applied to these users. Next, you'll need to configure and deploy NSS VMs and send NSS feeds to your SIEM for cloud firewalls separately from web traffic. These logs can significantly boost your organization's visibility into traffic flows and help with troubleshooting, threat hunting, and breach investigation processes. Next, let's take a look at specific recommendations for building firewall policy. First, it's recommended that you block quick traffic. At present, ZIA is unable to perform SSL inspection for quick, so quick traffic will bypass security engines unless it is blocked. Blocking quick forces clients to fall back to TLS, allowing for inspection and policy enforcement on this traffic. Note that this rule should be placed above the Microsoft one-click rule, otherwise some parts of the OneDrive, SharePoint, and Microsoft login services flows will not be inspected when using Quick. Blocking Quick this way will make it impossible to use Quick to bypass your security policies, decreasing the overall attack surface. Next, it's important to use the network application and network services match criteria together. If you don't do this, it's possible to use allowed ports for non-standard protocols, for example, sending HTTP traffic over the SSH port, to circumvent firewall policies. The network application criteria uses DPI instead of L4 ports to classify traffic. Using both criteria together locks legitimate applications down to known ports. For advanced cloud firewall, it's recommended that you also leverage user identity criteria to further narrow your policy, by using user groups as a match criteria. This is because it's recommended to be as specific as possible with firewall rules to avoid accidentally allowing traffic through. Again, note that the user criterion is limited to 4 per rule, and it's also tied closely to IDP attributes. It's recommended that you leverage user groups instead for more flexibility. Next, it's recommended that you avoid using URLs in firewall policy. This is because full URLs are not visible unless traffic isn't encrypted, since firewall policy is applied before the SSL inspection policy engine makes a decision to decrypt traffic or not. This means that only the host portion of the URL is examined. Note also that URL categories are not pre-resolved, in contrast to IP address or wildcard FQDN criteria, which restricts the rules to web traffic only, unless IP addresses are specified as well. Note that the ability to leverage FQDNs for firewall policy is specific to the Advanced Cloud Firewall license. For people with the Advanced Cloud Firewall license, it's highly recommended that rather than IP addresses, you rely on FQDNs to target your policies. This is because IP addresses typically represent backend entities such as servers and can be subject to change without notice. On the other hand, users generally reach applications via a user-friendly FQDN, and these generally remain static since applications are directly associated with them. Building your policy with FQDNs instead of IP addresses means that your cloud firewall rules will not be affected by backend changes at the destination. Finally, also for advanced cloud firewall, it's important to avoid using wildcard FQDNs in the destination FQDN lists. This is because wildcard entries will match every FQDN in the specific domain, which will result in new destinations in the domain automatically being exempt from firewall policy. This can often result in something close to a failed open model, and is heavily discouraged from a security perspective. It's recommended that you build policy with specific destinations only to ensure that all traffic that is not explicitly allowed is blocked by the firewall module. Note also that when configuring wildcards, the star symbol in wildcard entries is not supported. The correct format is to use a leading dot. That's it for this video. Thank you for watching.